Chapter 14, the Skeletal System, Part 5. Bone growth. Early in the development of a human fetus, the skeleton is made almost entirely of cartilage. The relatively soft cartilage gradually turns into hard bone through a process called ossification. So here's a step-by-step process here that we'll talk about. Steps of bone growth. A cartilage model of bone forms and continues to grow. So a model would be like a basic shape, but is composed of cartilage. Ossification begins at a primary ossification center in the middle of the bone. This generally appears during fetal development, but a few short bones begin their primary ossification after birth. Ossification extends toward both ends of the bone, eventually forming the shaft of long bones. Ossification from the secondary ossification center, which forms after birth, eventually forms the ends of the bones. The medullary cavity forms and will contain the red bone marrow. Areas of ossification meet at epiphyseal plates and articular cartilage forms. This is the smooth cartilage on the end. The shaft and ends of the bone are separated by a growing zone of cartilage until the individual reaches skeletal maturity, and then bone growth ends. But of course, maintenance continues. Skeletal maturity. Throughout childhood, the bone-destined cartilage remaining in the skeleton keeps being replaced and the bones grow in length. However, once all the cartilage has been replaced by bone and fusion has taken place at the epiphyseal plates, the bones can no longer keep growing in length. This is the point at which skeletal maturity has been reached. It generally takes place by age 18 to 25. The use of anabolic steroids by teens can speed up the process of skeletal maturity, resulting in a shorter period of cartilage growth before fusion takes place. This means that teens who use steroids are likely to end up shorter as adults than they would otherwise have been. So this is a place where I'd like to remind everybody that eventually I'm going to assign a poster project, and this might be an interesting topic for someone to choose. Bone remodeling. Even after skeletal maturity has been attained, bone is constantly being resorbed and replaced with new bone in a process known as bone remodeling. In this lifelong process, mature bone tissue is continually turned over, with about 10% of the skeletal mass of an adult being remodeled each year. Bone remodeling is carried out through the work of osteoclasts that resorb bone and dissolve its minerals, and osteoblasts, remember B is for building, that makes the bone matrix. Bone remodeling shapes the bones of the skeleton as a child grows, repairs tiny flaws in the bone that result from everyday movements, makes bones thicker at points where muscles place the most stress on them, helps regulate mineral homeostasis by releasing minerals from bones into the blood or absorbing minerals from the blood into bones. Control of bone remodeling. The action of osteoblasts and osteoclasts in bone remodeling and calcium homeostasis is controlled by enzymes, hormones, and other substances that either promote or inhibit the activity of the cells. These substances control the rate at which bone is made, destroyed, and changed in shape. For example, the rate at which osteoclasts resorb bone and release calcium into the blood is promoted by parathyroid hormone, produced by the parathyroid gland, and inhibited by calcitonin, produced by the thyroid gland. The rate at which osteoblasts create new bone is stimulated by growth hormone, produced by the anterior lobe of the pituitary gland. Thyroid hormone and sex hormones, estrogens and androgens, also stimulate osteoblasts to create new bone. I'm going to just look at this figure for a minute. So keeping the calcium level in homeostasis includes the work of osteoclasts and other bone types. If calcium levels increase, the thyroid releases calcitonin, which inhibits osteoclast activity. So that inhibits the breakdown of bone. This results in less calcium being resorbed in the kidneys, which results in the lowering of calcium in the blood. If the calcium levels decrease below this set point, The parathyroid gland releases parathyroid hormone. This causes osteoclasts to release calcium from bones and increases calcium absorption in the kidney and small intestines. This brings calcium back to homeostasis. Bone repair. Bone repair is the process in which a bone heals itself following a bone fracture. Before this fracture heals, usually a health professional must push the displaced bone parts back into their correct positions. Then the bone must be stabilized, for example, with a cast or pins surgically inserted. Then the bone's natural healing process can be completed. The process may take several weeks. The process of bone repair is mainly determined by the periosteum, the connective tissue membrane covering the bone. The periosteum is the primary source of precursor cells that develop into osteoblasts, which are essential to the healing process. Bones heal as osteoblasts form new bone tissue. Bone repair. Although bone repair is a natural physiological process, it may be promoted or inhibited. For example, a fracture is likely to be more successful with adequate nutrition intake. Age, bone type, drug therapy, and pre-existing bone disease are additional factors that may affect healing. Bones that are weakened by diseases such as osteoporosis or bone cancer are more likely to fracture and heal more slowly.